Have you ever looked up at the night sky, studded with countless stars, and felt a profound sense of wonder? You're seeing history, light that has traveled for thousands, even millions of years just to reach your eyes. But here's the cosmic kicker. Everything you see, every star, every galaxy, every glowing nebula, is only a tiny fraction of what's actually out there. It's a mere 5% of the total cosmic inventory. So, what makes up the other 95%? What is this invisible stuff that dominates the universe, shaping its destiny in ways we are only just beginning to comprehend? This is one of the biggest, most humbling questions in all of science. The universe, it turns out, is playing a grand game of hide and seek. For centuries, we mapped the stars, discovered planets, learned about gravity, and built powerful telescopes. But the more we looked, the more we realized that our understanding was incomplete. The universe wasn't behaving as it should. There was a mysterious something out there, a cosmic question mark whispering that the greatest discoveries were hidden in plain sight. Imagine you're trying to weigh a giant carousel just by how fast it spins. If it's really fast, it must be heavy. But add up the horses, lights, and decorations, it's not enough. You'd conclude there's invisible weight. That's the puzzle with galaxies. The math didn't add up. An enormous invisible elephant. The motions of stars told a story of gravity beyond visible matter. This is where our journey into the dark begins. We are cosmic detectives, following gravity's clues, confronting our limits, and thinking beyond light and matter. So, what is this invisible stuff holding galaxies together? Scientists call it dark matter. The name is simple, but the concept is profound. It's dark because it doesn't interact with light. It doesn't shine. It doesn't reflect. It doesn't cast a shadow. It's completely transparent to every kind of light we can detect, from radio waves to gamma rays. If you could hold a clump of it, it would be utterly invisible. You wouldn't see it, but you would feel its weight. It's the strong, silent type, known only through gravity. Astronomers watched galaxies spin and saw outer stars moving as fast as those near the center. By our expectations, outer stars should slow down. Only a massive, invisible halo could keep them in orbit. That halo supplies the extra gravity. Think of it like a cosmic pizza. Stars, gas, and dust are the toppings. The real mass is the dough, dark matter. Without that scaffolding, galaxies would tear apart. But what is it? That's the trillion-dollar question. If dark matter is the universe's invisible glue holding things together, then there's another, even more mysterious force doing the opposite. We call this force dark energy. While gravity and dark matter pull galaxies closer, dark energy is a repellent, expanding space-time faster and faster. It's an anti-gravity force woven into the vacuum of space. This discovery in the late 1990s shocked astronomers. For most of the 20th century, two fates seemed likely: Big Crunch, or endless expansion, slowing down. Think of tossing a ball. No one expected it to speed up instead. But distant supernovae showed the expansion isn't slowing, it's speeding up. Galaxies are receding faster and faster. The universe has a foot on the gas, dark energy in space. It makes up about 68% of the universe. Unlike dark matter's clumps, dark energy is uniform. More space means more dark energy, a feedback loop driving a lonelier future. The universe is weirder than we can imagine. The study of its dark side is full of mind-bending ideas. Here's a fun one. Dark matter doesn't seem to interact with itself. Normal matter bumps and sticks together to form stars and planets. Dark matter particles pass right through each other like ghosts. That's why it forms tremendous, diffuse halos, not dark matter planets or dark matter stars. In galaxy collisions, gas smashes, but halos pass through almost unscathed. Dark energy seems ancient but only recently became dominant. Early on, matter density was high. Gravity overpowered dark energy. As space expanded, matter diluted. Dark energy, a property of space, stayed constant. About 5 billion years ago, Dark energy took over and acceleration began. Add up the universe. You, me, Earth, and all the stars. Only 5%. Dark matter about 27. Dark energy about 68. 95% of the universe is mystery. We're just beginning to chart these dark seas. The map is almost blank. Einstein's cosmological constant, once his blunder, now looks prescient in the age of dark energy. So why does any of this matter? We have problems right here on Earth. Why spend resources chasing invisible phantoms across the cosmos? The answer lies in our humanity, curiosity about our place in the universe. Learning we're made of a rare 5% is humbling. It connects us to a grander, mysterious story. This isn't academic trivia. It's our origin and destiny. Galaxies, stars, and planets formed on dark matter's scaffold. Without it, matter would have stayed too diffuse to coalesce. Our future is shaped by dark energy's relentless push. The quest drives innovation, ultra-sensitive detectors, powerful telescopes, and new technologies that inspire the next generation. These challenges make us smarter, more creative, and more ambitious. Looking into the dark is looking into ourselves. The universe is filled with wonders just beyond our understanding. Answer one question. 10 more appear. That's exciting. By exploring the unseen 95%, we fulfill our deepest impulse: to explore, to question, and to know.